Okay, so this is our second part for areas between curves. Let me actually make sure I'm on the right page. Yeah, I am, okay. Okay, and all I'm really adding here is if we're intersecting at more than one part, and I scrolled up because I want to show us, like, here we were intersecting at these 2 points. So we only had one little region of area we were looking for. But today, I want it to be we're intersecting at more than 2 points, so we have different sections of area, and that's the piece that we're adding today. Okay, but we're still gonna think about this just the same way, and let's just break it into pieces of what we know how to do. So let's first look at this part here on the left that's about to be shaded yellow in a second. And then we'll look at the piece on the right, which I'm shading in blue. And I shaded more than the area here, but I kind of just want us to see the region. For this first piece here, we're going from 0 to 2. So let's set up our integral. We're going the integral from 0 to 2. And which function is on top? Which is our bigger function? Well, this is the straight line. And I know that the straight line is y equals 10, so we're going to have 10 minus. And then what's our smaller function? Our smaller function is 7x minus x squared. And I'm doing a little bit of different notation than I've been doing, but it's still the same thing. I'm just putting the parentheses around the whole thing. Because that's the way it's shown a lot on the AP test. And to me, I don't particularly care if you write that, but I want you to be familiar with recognizing it's the same thing. Okay, so this is our first area. That's this area right here. Let me actually erase this whole yellow thing and shade only the area that we found. We found this area. And now we still need to find the area of the blue piece. Well, that blue piece is going from 2 to 5. The area from 2 to 5. But now our top function is the curve, so our top function is this 7x minus x squared minus, and now minus our straight line, which is 10. And we get that. Okay, I do want you to keep going with this, but I'm not going to show all the work for it. So go ahead and pause the video now, try and find these integrals on your own, and when I come back, I'm going to have it all worked out and we can check to see if we get the same answer. Okay, I'm back. I've worked through the whole thing. I'm not going to talk us through every part of the process, but I will talk us through a little bit of it, specifically one part. So I just computed the integral, that was this step here, and then my next thing, I wrote it all out. 2 shortcuts I kind of did. First shortcut is I saw that I was plugging in 0, all these terms have an x in them, so this is just going to go to 0, so I didn't write that out. That's where the 0 came from. But the other part I want to talk about is these things I highlighted in green, because I made a clever observation, because I could have done all the math for this, but I noticed that this stuff here, this negative 1/3 2 cubed plus 7 over 2 2 cubed minus 10 over 2, 10 times 2, that's the same thing as this here, except the signs are all flipped. Well, I have a negative in front that I'm going to distribute. That's going to make the signs all the same. So this piece is the same as that piece right there. So I have the same thing twice. Well, I just did 2 times. Maybe I should have highlighted that. 2 times that piece. Instead of doing all this math twice, I just said, well, I have 2 of the same thing. And that saved me a little bit of time. I would go through and check my algebra just to make sure it's right. And if you make any mistakes, you can let me know. But that's how I would have gone through and done this one. Okay, next one, we're not going to have to do the actual area. I specifically asked for an integral expression, And that means that once we get the integral written, we can stop. I don't need a full sum. Like here I said write a sum of the areas, so this would be our sum. Here I'm saying write an integral expression. This means I just want an integral. So this part up here is where we would have stopped if I'd just asked for the integral. Okay, but this one, the figure above shows the graph of y equals 2 sine x and the line y equals 1. Well, clearly this line right here is y equals 1, and our 2 sine x is the parabolic shape. From 0 to pi, we want to write our integral expression. Okay, well here, they don't, hold on one second. Okay, they don't tell us where these are intersecting, so we're going to have to find that point of intersection, these 2 points of intersection. Okay, and I know before I said we were really looking at if they intersect more than twice, looking at these lines actually only intersect twice, but the bigger thing is like if we have more than one area, I guess is a better way to say it than if we have more than 2 points of intersection. I don't know why AP Classroom calls it more than 2 points of intersection when it's really not that, but anyway. Okay, so if we're looking at this first section, let's find our points of intersection. So how do we find points of intersection? We just set our functions equal to each other. So we have 2 sine of x equals 1. We're going to solve this. Sine of x equals 1/2. I forgot to refresh it. Hopefully we know our trig functions very well. This is going to be x equals pi over 6 and 5 pi over 6. All right, and now we have our points of intersection. I'm just going to go ahead and label them on my graph. Pi over 6, 5 pi over 6. And now all we're doing is we're writing this integral. Remember, it's going to be our bigger function minus our smaller function, our top minus our bottom, above minus below. Why don't you go ahead and try writing it on your own, just the integral expression. And when I come back, I'm going to have it written out and I'll talk us through it a little bit. Okay, I'm back and I wrote it out. I'll talk us through it a little bit. So I just looked at each area. So our first area was going from 0 to pi over 6. So I got these bounds. And our top function was the 1. So I did 1 minus our bottom function, 2 sine x dx. Then I just moved to our middle piece. What are the bounds? Pi over 6 to 5 pi over 6. And our top function here was the 2 sine of x. And we subtracted 1 for this area right here. And then our last one, 5 pi over 6 to pi. And that's just 1. Our top function again was the 1, and our bottom function was the 2 sine of x. Okay, so that one was pretty quick. The only tricky part here was finding these points of intersection. All right, and our last one, I changed it. I decided I didn't want to do another trig function, so I changed it to this because I think this is slightly more interesting, although it's still not a very interesting question. But I actually want us to do it algebraically without a graph. So I'm actually going to give us a sort of step list here. We have our 2 curves. What I want us to do first is find points of intersection. So this is sort of our first step. And we're just going to do that by setting our functions equal to each other because they intersect where they're the same. Oops, sorry. There we go. All right, and I'm going to go through solving this pretty quickly, but I'll show my steps along the way because I'm very confident that we will be confuzzled by this question. So first, I'm just moving everything to the same side. I want to get all my x's on their own. I can tell intuitively that I'm going to be factoring here because I see a cubic function. And then after that, I factor out my greatest common factor, the 2x. And then this x squared minus 1, well, that is just our difference of squares. So that's our x plus 1, x minus 1. And now from there, hopefully it's sort of clear what's going to happen. This piece here is 0 when we're -1. This piece is 0 when we're 0, and this piece is 0 when we're +1. So our solutions to this are -1, 0, and 1. Okay. These are our points of intersection. Okay. So there's step 1. Step 2, I want to figure out which is the top and bottom. All right. And to do that, we're going to still sort of think about our number line. And I'm actually going to start by drawing a picture. And my picture is going to be very simple. It's going to be 3 dots. Boom, 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 which are showing up now. And I'm going to label them x equals -1, x equals 0, and x equals 1. And I don't actually care what's happening between these points. That looks like a y, sorry. All I care about is which function is on top and which function is on bottom in between these points. All right. And so let's just figure out which one's going to be on the top in between this area. So let's look at a point in between -1 and 0. Let's say -1/2. So if we plug that into our x cubed minus x, so we have -1/2 cubed minus 1/2. Well, that equals -1/8. I'm sorry, I was about to make a mistake. Fortunately, I caught myself. Just rewrite this. Hopefully y'all can see it. This is minus -1/2, so that's going to become plus 1/2. And hopefully you can get that on your own, but this is going to end up being 3/8. And before, when I had us do it, I had us check both of these, but I want to make a clever observation here. So I want to notice that x cubed minus x is equal to negative x minus x cubed. The only difference between these functions is I multiplied by a -1. So if this one here is positive, my other one is going to just be negative because all I did was multiply by -1. So that means that this one, this positive one, has to be on top. So let's draw that on our curve. So on top, for this first part, we're going to have x cubed minus x. And on the bottom, we would have our x minus x cubed. And what's happening with these curves, I don't know, I don't care. These curves could be right, they could be wrong, it doesn't matter. All I care about is that this one's on top, that one's on the bottom, and we have this little area section. Okay, and now let's check from 0 to 1. We're going to check positive 1/2 now. So 1/2 cubed minus 1/2. That's just 1/8 minus 1/2, which is just equal to -3/8. And again, this function here is just the negative version of this. Well, negative times negative is a positive. So our top function here is actually this x minus x cubed. And then our bottom function is the x cubed minus x. Okay, and now we can set up our integral expression. I'm gonna I want you to pause the video, try and write the integral expression. You come back. When I come back, I'm going to have it written. I'm not really going to talk through it. Okay, so I wrote the integral. You can check to see if you got that right. And now we're actually just going to go through and we're going to compute this integral and simplify. Again, I'm not really going to talk through it, but I'll work through it and you can work through it. And when I come back, we'll have it. And if I do anything interesting, I'll talk about that. But other than that, we'll just keep it moving. Okay, so coming back, I didn't really do any clever things. I'm sure I could do a clever step with about the fact that these are reflections of each other, and this is a symmetrical interval, I guess. Surely there's something you could do there, but the only thing I really did is I noticed again that the zeros, those are just going to go to 0 because every term has an x in it, and then I just computed it. But feel free to look over this. Our practice is up on Formative. Thank you for watching.